Okay, we're going to finish up mean value theorem from section 4.2 in this video. This is example number 3b. It asks us to find c that satisfies the mean value theorem for this function on the interval excuse me, from -3 to 4. And so remember, mean value theorem says two things. Number one, your function has to be continuous and differentiable. Number two, if that's the case, then the mean value theorem says that the average rate of change should be the same as your instantaneous rate of change. The slope between your two endpoints should be the same or equal to your derivative. Okay? So, looking at my function, would you say that this function is continuous and differentiable? Well, it's just a polynomial function, or more specifically, a quadratic. I know it's going to be a parabola, and so in a parabola, I know that a parabola is always continuous. There's no sharp turns, points of discontinuity, anything like that. So this function should be continuous and differentiable. So I know that that first one is satisfied. Number two, the derivative has to be the same as my average rate of change. The slope between my two endpoints has to be equal to my instantaneous rate of change, my derivative. So let's go ahead and do those two pieces. I need you to find me the slope between your two endpoints. Well, I know one of my endpoints is at x equals -3. My other endpoint is at x equals 4, but I don't know the y values. So like we did in the last example, I need you to take the -3 and the 4 and find me the y values that correspond to each of those x values. Remember, we're plugging those -3 into my original function. We're plugging the 4 into my original function so I can find their corresponding y values. I ended up actually getting 0 for both, did you? And so now that I have those two endpoints, -3, 0 and 4, 0, we should be able to find the slope between those two endpoints, the average rate of change. So using my slope formula, I ended up getting a slope between my two endpoints of 0. So imagine what that would look like. So I know that I have two endpoints, one over here, and the slope actually happens to be 0. So I actually have a horizontal line. At some point along that interval, I have a function, or maybe it's not an upside down parabola, maybe it's a parabola that opens up, but at some point, doesn't this parabola also have a horizontal tangent? The average rate of change is the same as the instantaneous rate of change. So let's show that. So if I know that the average rate of change is 0, let's see what my instantaneous rate of change is. So I need you to find me the derivative of this function. And at some point, it should equal 0. It should be the same as the average rate of change. I got a derivative of 2x minus 1. I'm going to set that equal to 0, and I'm going to solve and find the place in the interval from -3 to 4 that has the same average slope as my instantaneous slope. I ended up getting x equals, or c equals, 1/2. That satisfies the mean value theorem. Okay. All right, the last one we're going to do in this section is C. Part C says find that x value or that c value that satisfies the mean value theorem for this function on the interval from -2 to 2. So remember the two things that we need to show for mean value theorem. Number one, it has to be continuous and differentiable. And number two, the instantaneous rate of change has to be the same as my average rate of change. So the first thing here, we need to show that this function is continuous and differentiable in my interval. Okay, don't make fun, as usual. There's my red flag. Did you have a red flag? Well, hopefully you noticed from the beginning that there's a vertical asymptote. And I know that there's a vertical asymptote at x equals 0, right? That's going to cause my function to be undefined. And so if I'm looking at the interval from -2 to 2, isn't that vertical asymptote right there in the middle of my interval? And so the first thing that has to happen for mean value theorem is that my function has to be continuous or differentiable. If it's not both of those two things, well then I can't guarantee mean value theorem will apply. So as soon as I see that there's a vertical asymptote right in the middle of my interval, I've got to be able to say then that mean value theorem does not apply. I cannot guarantee mean value theorem will work because my function is not continuous and also not differentiable. So I said mean value theorem does not apply for this problem. I can't find or guarantee that there is a C that satisfies the mean value theorem, so I'm done.